Hello again. This bridge is in Budapest, the capital of Hungary. While having a walk there with a friend, we had a conversation about the design of this bridge, and he thinks these cables are there only for decoration. So I decided to make this experiment and this video to explain the role that these cables play. This is a simple model for the bridge without having any cables. As you can see, the deflection is crazy, and there is no stability in the system at all. In other words, the system fails here. By adding some cables, we will have this result. As you can see, the structure doesn't go below the red line, which means we don't have that crazy deflection anymore. So what is happening here? Let's go to SolidWorks and simulate the case. So let's start with the first case. Here we have the simple structure, and we have the gravity load, and then we have these three members loaded. Each one is loaded with 1000 kilogram force. And let's see the results. Here we have failure because we have stresses over the value of the yield strength here, which means this structure will definitely fail on this kind of load. And about the displacement, we have around 200 millimeters of displacement, which is a lot in such a case. On the other hand, if we have the same structure but with some cables added, and here for the stress it's 1.9 multiplied by 10 to the power of 8, and for the displacement it's around 28 millimeters. For the load, it's the same load, and here you can see we have these three members loaded, and each one is loaded with 1000 kilogram force. So this is the difference that these cables make, and notice how the maximum stress we have here is 1.9, and on the other case is 7.7. If we define a factor of safety plot here, as you can see, the minimum factor of safety we have is 1.27. Thanks for watching, and see you in another video.